Last problem. So we want to show that we have the following identity for x greater or equal to 0. So let us call this as f and this one as g. If we take the derivative of f, we have 2 over square root of 1 minus x squared, and the derivative of g is 1 over square root of 1 minus, so this is negative 1 minus 2x squared and then multiply by the derivative of the inside, negative 4x. If we simplify this, we have negative 1 times negative 4 is 4x divided by square root of 1 minus 4x to the 4th plus, this should be minus 4x squared plus 4x to the 4th. If we simplify further, we have 4x divided by, we can cancel the 1, so 4x squared minus 4x to the 4th. This is 4x. Note that this 2 term has x squared as a factor, so we can factor out x squared. Minus, actually we can factor out 4x squared here. So square root of 4x squared. So here we have 1 minus x squared. So remember that square root of x squared is absolute value of x. So we can write this as, let me write over here, 4x divided by 2 times absolute value of x. Now remember that the problem is only care about x being greater or equal to 0. So if x is greater or equal to 0, then absolute value of x is equal to x. For x so this simplifies to 4x 2 over square root of 1 minus x squared. And we can see that this expression is exactly the derivative of f. So we have that, so f prime of x equals g prime of x for all x greater or equal to 0. Okay, so first we just use this fact for x bigger than 0 because we would just want to use the fact on the open interval. Since the derivative is equal on this open interval, then by the corollary f minus g is constant. On x greater than 0. First, let us rewrite what we want to prove. So we want to prove that 2 sine minus 2 arc sine x equal cosine 1 minus 4x squared. Now for x equal 1, this is f, right? So for x equal 1 we have 2 arc sine 1. What is 2 arc sine 1? So arc sine 1 is the left hand side is equal to 2 times pi over 2, which is pi. And arc sine of, let me check again the problem, I think I didn't copy it correctly, should be cosine 1 minus 2x squared. 1 minus 2x squared here. So if we plug in x equal 1 there, then we are looking for arc sine of negative 1, which is also pi. Okay, so the two are equal. It means, so this is f, remember, so this is f of 1, and this is g of 1. So from this we know that f of f minus g at 1 is equal to 0. But it says in the before that f minus g is constant on the interval x greater than 0. So since we already know that for one particular point the value of f minus g is equal to 0, then it follows that this f minus g is constant and equal to 0 for all x bigger than 0. So f minus g equal to 0 for x bigger than 0. Now the statement that we want to prove is we want to prove that this is equal for all x greater or equal to 0. We want to prove that f equals to g. We want to prove this f equals to that g. So for x equals 0 we can check manually. For x equals 0, the left hand side is 2 arc sine 0, which is 0. So check manually. For x equals 0, the left hand side is equal to 0, and the right hand side, so if we plug in x equals 0, we want arc cosine of 1, which is also 0. So f also equals to g when x equals 0. It follows that this holds true for all x greater or equal to 0.